Hello everyone, today we're going to be learning about the kinetic particle model. And I know it sounds like a lot of big words there, right? Don't worry, it's actually quite easy. Okay, so let's dive into it. Okay, so firstly, let's do a quick recap on what are the three states of matter. So there is a solid state, there's a liquid state, and there's gaseous state. Okay, so now solid state has fixed shape and also fixed volume, cannot be compressed because there's a fixed volume. You can't squeeze it around, you can't change the volume, and it has the highest density, and I'll explain why later on. Okay, so liquid has no fixed shape because think about it. If you put a liquid from this jar to another jar with a different shape, it will just take the shape of the jar, but it will not change its volume, and therefore they also cannot be compressed. Okay, it's sort of like a medium density. Solid is highest, this is medium. Of course, we are going on sort of like a scale, right? So gaseous state will be lowest density. Okay, please don't call it gas state, or I call it gaseous state, right? You only say this is a gas, but you don't say it's a gas state, you say gaseous state. Okay? Now, it has no fixed shape, which is right Fs, no fixed volume, and can be compressed because these two go hand in hand. The volume and compressibility, they go hand in hand. So if there's no fixed volume, definitely it can be compressed, right? What sort of thing has fixed volume but can be compressed, right? Okay, so now once we've learned all these, we're going to try to define what is kinetic particle model that I was talking about just now. Okay, so now it's actually super simple. Not much to remember, just one single definition of kinetic particle model. Okay, now kinetic particle model states that matter is made up of a large number of tiny particles. Okay, this is first state. This is point number one. Whether if you're answering a question like an exam question, what is the kinetic particle model? You must say it states that whether it's point one, large number of tiny particles is point one. Okay, point two is that these things are in continuous and random motion. So that's your point two. Continuous, point two. Random motion, point three. So it's basically just like a way of saying we have these particles over here. They are in continuous motion, so they will never stop moving. They will just keep moving here, moving there. And it's random motion. That means there isn't like a certain direction they are going. They can go here, they can go there, they can go here, they can go there. Alright? So that is basically what the kinetic particle model is about. Now we will talk about the kinetic particle model for all three different states of matter. Now, let's talk about the kinetic particle model for solid. Now, the definition states that it is made up of many different small particles. Now, these particles can be atoms, can be molecules, can be ions. Okay, but there are these small particles inside of a solid. Now, solid is the densest, And of course, you know what densest means, right? The most closely packed. So these balls that I'm gonna draw are gonna act like the particles. And you can see they are really closely packed against each other. And it really is just completely packed up. You can see that, right? So that is solid. So as you can see over here, these are the solids. They are packed in this way. And you get, okay, now let's look at the arrangement of these solids. Okay, so firstly, they are closely packed, as you can see. There's like minimum gaps. Actually, there are not supposed to be any gaps between them. It's supposed to be like stuff like this. They're completely supposed to be touching each other. Okay, but because I can't draw that accurately, but it's supposed to be like, yeah, like touching each other. Okay, so closely packed, first thing. Now, another part of the arrangement is that it is an orderly arrangement. So it's not random. It's just really just packed together. Okay, it's not random. But here's the thing, they cannot move freely. Okay, they cannot move freely. But they still vibrate sort of. Right? So although they cannot move freely, but they sort of vibrate in their fixed position. So they're like trying to like, break apart, but they can't. Now, they are held in position by strong IF. IF stands for intermolecular forces. So these solids, these particles are really connected by these strong intermolecular forces that it's very hard to break apart. Okay, and that really explains why they're fixed volume, fixed shape, and higher density. Okay? Alright. So now let's move on to liquid. So how do liquids work? Now, it's basically, of course, they'll be a bit looser. So they will sort of break apart a bit, but they will not really like all over the place. There'll be, you can still sort of see like there's some connections in the IF. You can still sort of see connections here and there, right? But it will be weak. Not as strong as solid. Solid is really just packed together. This one isn't. So let's go through. They're closely packed. They're still sort of closely packed, right? You can still sort of see that soft packed, but the arrangement isn't as orderly as the solids. It's not just like, whoa, just so neat and nice. It's a bit disorderly. Now, they're gonna have some sort of movement. It's not gonna be just like, oh, I'm gonna be fixed in place. No, they can actually move this time. They can sort of rotate and slide past one another. Okay? They're free to move, but they are confined within the space they're in. Okay? And the intermolecular forces is moderately strong. It's not that weak because at least you can still see that they're sort of confined. They can't move that wildly. That's why you can still see some form of intermolecular forces. And that explains why no fixed shape, fixed volume. Okay? Because, yeah, right, and density, medium. Because you can see, not that packed, right? You can still sort of see this thing. Okay, so now let's move on to gaseous, which is going to be the last one. Okay, remember. Okay, it's taken a long time. Okay. Alright. Now, gaseous state. Can you guess how it will be like, how it will be arranged? The gaseous state while I'm wiping the board. Okay, gaseous state is going to be interesting. It's the intermolecular forces are going to be so weak, so weak. Okay, so gaseous. Last one. Okay, what the world is this? Okay, sorry about that. I wasn't intended. Okay, so gaseous is really just completely wow already. It's so far apart, it's so disorderly. So it'll just all be like this. Really, there's not much link over here. Okay, and they're all like gone. That is literally how it's like. So they are really far apart, and they obviously have a very disorderly arrangement. Okay, now they really can just occupy whatever space there is. They don't really care. That's why there's no fixed volume, and that's why they have low densities as well. So weak intermolecular forces, and gases are really the ones, the main people who really just move about randomly at high speeds. It's just bouncing around, ricocheting around. Yeah, that's why they have no fixed volume, no fixed shape, and of course super low density because they're so loose, so far apart, just completely not regarding anything. You know, just occupy whatever space there is. That's why they're such low density. Okay, so thank you everyone for listening in, and hope you have a nice day ahead. If this helped you, please consider liking and subscribing. Share this to whoever needs to learn this, wants to learn this, and if you have any questions, you can comment down below. I will be sure to answer them. Okay, and thank you very much. Have a nice day ahead. Peace.